Look at your own face in the mirror. Now imagine splitting it exactly in half and flipping one side to match the other. Would it look the same or would it feel slightly different? Maybe even unnatural. Now, here's the interesting part. Research shows that people are often rated as more attractive when their faces are more symmetrical. At the same time, perfect symmetry doesn't always look the best. So, what exactly is going on here? Why does the human brain respond to the symmetry at all? And why does perfection always win? To answer that, we have to go deeper into how the brain actually processes faces. When you look at a face, your brain is not just seeing features, it is analyzing patterns, spacing between the eyes, alignment of the nose, balance between the left and right sides. This happens extremely fast, within milliseconds. And this processing is part of what researchers study in areas like cognitive neuroscience. The brain prefers patterns that are easier to process, and symmetrical faces are more often easier to process. This is linked to something called cognitive fluency. When something is easier for the brain to process, it tends to feel more familiar and more pleasant. So symmetry doesn't just look good, it feels easier for the brain to understand. But ease of processing is only one part of the story. There is something deeper. In biological research, facial symmetry is often discussed in terms of developmental stability. As the body develops, it is influenced by many factors: genetics, nutrition, environmental stress, and illness. Perfect symmetry is almost impossible. But lower levels of symmetry can suggest that the body developed under relatively stable conditions. This is why symmetry has been processed as a possible indicator of developmental health. The idea is not that symmetry guarantees health, but that it may correlate with it at a population level, and the brain over time may have become sensitive to these patterns. If symmetry signals stability, why doesn't perfect symmetry always look at most attractive? Interestingly, studies where faces are artificially edited to be perfectly symmetrical often show something unexpected. People do not always prefer the perfectly symmetrical version. Sometimes it feels unnatural, even slightly uncomfortable. Why? Because the human brain is not used to perfect symmetry in real faces. Real faces always have small variations, and these variations may actually help the brain recognize individuality. Perfect symmetry can reduce that uniqueness. It can make a face feel artificial. So the brain seems to prefer a balance. Not too asymmetrical, but not perfectly symmetrical either. So symmetry matters, but it is not acting alone. Another important factor is how symmetry influences perception beyond appearance. This is where a concept called the halo effect comes in. When a face appears more symmetrical and balanced, people are more likely to assume intelligence, trust, and competence. These assumptions happen automatically, even when there is no real evidence. This shows that symmetry doesn't just affect attractiveness, it affects how the brain interprets a person as a whole. But attraction is not based only on static images. something else changes everything. When a face moves, symmetry is no longer just about structure. It becomes the coordination, facial expressions, timing, and micro movements. Research suggests that dynamic expressions can influence attractiveness more than static symmetry. A face that is slightly asymmetrical at the rest can appear more attractive when it expresses emotion naturally. This is because movement provides additional information, emotional responsiveness, social communication, neurological coordination. So, symmetry in motion is different from symmetry in stillness. And now we reach an important shift because symmetry is only one part of a larger system. When the brain evaluates a face, it does not isolate symmetry. It combines multiple signals: skin quality, facial proportions, expression, and movement. Symmetry is just one component, and sometimes other factors can overweight it. For example, strong emotional expression or confidence can increase perceived attractiveness even if symmetry is not high. This shows that attraction is not controlled by a single variable. It is a multi-factor system. And this leads to a deeper question. Is long-term interactions the importance of symmetry decreases? As people interact, the brain begins to prioritize behavior, personality, emotional connection. So, symmetry may influence first impressions, but it does not determine long-term outcome. So, what does all of this tell us? Facial symmetry matters, but not in a way people often think. It is not a rule, it is a signal that the brain uses as part of a larger system of prediction. Symmetry can make faces easy to process. It may correlate with developmental stability. It can influence first impression through perceptual biases, but it is not the full story because attraction is not based on a single feature. It is based on how multiple signals interact over time. And once you understand that, you start to see faces differently, not as fixed measures of beauty, but as complex patterns that the brain is trying to interpret. The brain prefers what it can understand easily, but what it understands easily is not always what matters most.